Hello. Hello, everybody. Welcome. Welcome to my TED Talk, as it were. Hope you all are having a great day. Today, we're going to be talking about the Certified Developer Associate Domain 3 for AWS. So I hope you all are in the right place. If not, there's probably another classroom down the hall. So to get things moving, who am I? I'm this guy. I'm Will Meadows. I'm a senior AWS content creator over here. And I've been working with AWS for, 4 years now or so. And it's definitely been a journey. And I think that's what you'll find as you work your way through the content. And as you sort of explore the space, there's a lot of work to be done. There's a lot of journeying to do. So don't feel too bad if some of the stuff doesn't all make sense at first. So anyways, let's talk about what we're here to talk about. You want to take a test, probably, or someone told you had to. And this specific talk is on domain 3. And when we're talking about the various domains, you can see there's a different amount of weight for each domain. And they've given me the one that's the biggest. So pay the most attention to my talk. Don't look at anyone else's TED Talks. All right. So at 30% of the overall weight of development with AWS services, this section is mostly talking about like, how do you AWSify things? That's sort of the best way I can give you. So how about we just hop in a little bit and get going. Oop, here we go. So inside this domain, we've got 4 subheadings that we're going to talk about, which is how to write code for serverless applications. And that's, we're going to touch into that in a different direction than you might be thinking. How to translate functional requirements into application design. That one's fairly straightforward. How to implement application design into application code. Spooky. And then how to write code that interacts with AWS services by using APIs, SDKs, and the CLI. Also kind of spooky. We'll talk about that in sort of a question format. Those last 2 ones are going to go quick through the presentation. This first beginning one's going to go slow. And by slow, I just mean there's a lot more of it. And in general, the lecture as I go through it should be more of a capstone. So if you find that you don't know a lot about what I'm talking, it might be good to go do a lot more review before you think to take the test. These are like $150, so make sure to take them when you're ready, and try not to do them too early. All right. So when we're talking about writing code for serverless applications, what does that even mean? Well, these are the 3 different serverless-y things, in my opinion, that you can kind of write some code for. We have AWS Lambda, we have Fargate, and we have step functions. These are 3 powerhouses of the serverless sort of sphere. Lambda is the bread and butter device that we use to create and to do function code. Fargate is a serverless container service, and step functions is a serverless orchestration service. So it's very important that you know about these 3 things. Although for this talk, I'm going to ignore the middle one because I got to choose. So we're just going to talk about the other 2. I think they're more important. So when we think about Lambda here, let's sort of dive in. Why are we even using Lambda? It's a serverless thing. So what is the difference between working with serverless versus working with servered? In general, as you can see what I've written here, it's about bite-sized chunks that do very specific tasks. Your Lambda functions aren't going to be your whole monolithic monster that does everything for you. They are the functions. They are the little bits of your application that do specific things. And one of the difficulties when you have to work on sort of like a function basis is you can't really have persistent data between these functions internally, right? Since we're only dealing with usually 1 function at a time. Which means if you do want to store information between iterations of functions or in between different instances of them, you have to do it externally, like in a database of some sort. So that's kind of a difficulty with dealing with serverless in this fashion. So it's something to keep in mind. And the other sort of high bar you have to reach or deal with is your code sort of times out after 15 minutes using Lambda, and your execution must finish within that time frame. Otherwise, it just sort of like vomits and dies. So if that's the sort of the fun part about serverless is either you're doing everything in 100 milliseconds, or oh god, it's taking way too long and it's going over the 15-minute time frame. So these are things that you have to keep in mind when working with servered versus serverless. and Lambda specifically. So I asked myself this question. I was just sitting here making this talk, and we're talking about writing code for serverless. What languages does Lambda even support? Like, this sounds like a silly question. It's like, what can you write your serverless code in? Well, you've got these, I don't know, is it 6 here? Off the top, Java, Go, PowerShell, Node.js, C#, Python, and Ruby. That might have been 7. Interesting. Those are some interesting choice languages to pick. And what about what runtime environment is this even based on? Well, as you can see here, they're Linux AMIs on the back end. So making sure your code actually works in a Linux environment, though it sounds silly, is something to be acutely aware of. Though it shouldn't be too hard if you have a standard sort of like programmery background. So another cute little feature of this problem is there's 2 different versions of the Linux AMI that this stuff gets built on. So you can see for Java down there, we have Java 11. It uses the Linux 2, and same thing with 8, except for this other version of 8, which uses the Linux 1. And you can see the other example for Python. So things to keep in mind when you're developing. Have a sip of your coffee. Okay. So what if I don't like any of those languages? What if I thought they're silly? Or I really love PHP. My God, I've been a PHP developer my whole life. I will die on PHP's grave. We go into battle together. You're going to need a custom runtime. So how do you make a custom runtime for Lambda? How do I do any of that? Well, AWS was kind enough sometime in 2019, I think, to give us these sort of like public HTTP endpoints to use to create custom runtimes, because they can receive the invocation events from Lambda, and you can see the 4 that are available here for you to dork around with, which is the next invocation, which sort of just pulls the next like Lambda call off the stack, invocation response, the error, and the initialization error. All good stuff that you can play around with. I'm not an expert at these 4 things. This was sort of newer to me, but it's important to know about because it leads us into our next dealy do, which is talking about Lambda layers. So this is the part of Lambda that will help you get all of that code that you wrote here, if you would decide to do this yourself, the custom runtimes, into Lambda itself. What is a Lambda layer? I'm just spewing a bunch of words at you. A Lambda layer is simply just the collection of whatever libraries that cool thing you just made needs, the custom runtime you've built to run your, let's say, TypeScript. I really want TypeScript to work on Lambda, or PHP. And any of those other dependencies you'd need to create this custom runtime gets all zipped up into a file, archived into a zip file, and is called a Lambda layer. Yeah, cool, whatever. Why does that matter? Why does it matter? Because then you can use things like TypeScript or Dino on AWS Lambda, like I've shown here. This is the GitHub page for it. You can go grab it down there at that link somewhere. Dino, for those of you who aren't familiar, is TypeScript, as I was mentioning, and it's written by the same people who did Node.js. So that's nifty. So for those of you who didn't want to program in any of these other 7 languages, and you want your own, you can use something called Lambda layers. How about we dive into that a little bit more? How do I actually do that in the console? Well, go to AWS, go to Lambda, click on the layers button, click create a layer, and then you get to upload that zip file we're talking about. And over here at that GitHub I was just looking at, they've already got some nice stuff example-wise. So they've got their layer here you can download, and they've got a cool example. You would upload this later for the function. And then there's a source code you can go check out to make sure you're not getting a virus or something strange, if that's so what you're choosing. Neat. So that's kind of one way to do it. But is there another way to sort of get our own code in here? There is. There's something strange that's out there in the wild, which is the AWS Serverless Application Repository. Why? What is this? What is this new thing? You keep throwing words at me, William. Well, it's a repo that has a collection, a huge collection of serverless applications, a bunch of code. Shh, go out there and steal it. Well, don't steal it, research it, as they say, and find the thing that works for you. But it's a store of shareable and reusable applications that are easily assembled, and they deploy serverless architectures. That's the marketing speech. What's cool about this, though, this repo, this one way to think about it would be like AWS Marketplace, but for free and for serverless, is all of this stuff here is packaged with something called SAM, which is the Serverless Application Model. Basically it's like CloudFormation, but more geared towards serverless. And in the end, it is just high-level CloudFormation. When you deploy something using a SAM template, it does just get deployed as CloudFormation with all of the fun benefits that come along with that. Interesting. I'm gonna take a sip of your coffee. The TED Talk requires much coffee. All right, what is SAM? Why do I care about the serverless application model? Well, back behind SAM and making your templates and all this cool stuff, SAM also has local deploying and debugging tools. If you've ever gotten tired of trying to make a function in your notepad or whatever you're using on your computer and then deploying it up to Lambda and saying it doesn't work and it's broken again, you can't figure out why. Boy, wouldn't it be great to have real debugging tools. Good news, AWS SAM, Serverless Application Model, has a CLI, allows you to build and test and debug all of your cool serverless code for writing your applications right there. So that's nice. I like that. I like it when things are made simpler for me. What does one of these look like, even like a template? It looks like this. No, this is a very simplified version, very minimal. Sort of outlining just one function. So as a serverless function, you can see here it's got a handler. You can see the runtime environment that it's working on. And look, we've got a little thing for layers. So if you wanted to do Dino, like we're talking about, you could put the ARN of your Dino layer right in that spot. Nifty. And over here on the right-hand side, you can see just like CloudFormation has a bunch of different options for you, like mappings, parameters, your outputs, cool resources, conditionals. So like, hey, I'm doing the small version of my serverless architecture, run this one, or if I'm doing the large production version of my serverless architecture, then do that one. That's what it means by conditionals. Neato burrito. It's a lot of information pretty quick. Don't forget, we have the question box on the side, and I will be notified when we have these question powers. So cool. Where does that leave us? Well, I didn't just bring up the serverless application repo for no reason. Inside is also Dino, that cool TypeScript language that I really want. So instead of having to go here and make it all myself, instead of having to go find the GitHub repo for my layers, we can find it inside of our the serverless application repository. It's by the guy who actually made it. Someone else did all the hard work of getting the layer up and into Lambda, making sure it works and it's tested, and they already put it up here in the serverless application repository. So all you have to do is press that deploy button up here in the top right corner. It takes it into Lambda for you, fills in all of the garbage that one must fill in, and you just press the deploy button down at the bottom right, and suddenly you've got a Lambda layer. That's crazy cool. The amount of work this used to take and the amount of work it does it now is impressive. So go look in the repository for anything that may float your fancy. If you're developing, just starting off, or whatever, I don't know, just Google some fun keywords and shove them in there, and who knows what you'll find that could save you hundreds of hours of your life. That's neat. Okay, so looking at this, we have a Lambda layer now. All this so we can write in PHP or Dino. I hated those 7 other languages, so these ones were way better. How do I actually get that to work? I've got a layer. Well, how do I use that? Well, plug it in here, author your function from scratch, and down here, select provide your own bootstrap on Amazon Linux 2. Remember, we talked about the cool different Linux versions, and then click create function. Inside, when you go look at your function, there's going to be a little layers thing. Trust me, you'll find it underneath your cool Dino app. Just click on that, and then you upload your layer. And we're going to grab the ARN. That's the cool thing from earlier, right here. See, version ARN. Grab that. Then you plug it in right there, and then you click add that layer. And wazam! You can now put. See, we got a little hello.typescript into our function code. You can upload your code then, or you could do it using the command line interface for SAM. And you got it all up in this guy, and then you can go ahead and just try it out and get a nice response code. That's awesome. And all that, sort of just dug in for this lecture. I was like, I don't want to use any of these languages. What is someone supposed to do if they want to write serverless code or write code for the service applications in something that's sort of non-native to Lambda? This is the process. And it may seem kind of like a random ramble, but layers will definitely be on your test. This is an important part of development and developing, is being able to work in languages that aren't necessarily supported by whatever service or application you're trying to build with. I don't know, I think it's neat. You let me know if it's neat. Okay, so that brings us to the other side of that strange three-headed hydra we looked at earlier, which is step functions. All of that before was talking about Lambda. Lambda is cool. It lets you do things like as a function as a service model, nano services. But one of the problems with step function with Lambda is it doesn't always want to behave the way you want it to behave. So we've got step functions here, which is Lambda's babysitter. Shh, it's all Lambda underneath. Don't tell anybody. And what it does is it allows you to create and manage, very powerful workflows. Think of whenever someone says step functions, it's really just like a vending machine or a state machine or a flow chart, really behind the scenes that says, you have these if-then powers that are really cool. Or you could like say, if you wanted to run like 2 Lambda functions back to back in a series, how would you even do that before? Would you have one Lambda function in the code, hard coded in, call a different Lambda function? What if you ever wanted to switch that out? Like that one function was no longer useful, like function B here. Like how would I switch that to something different? Well, you could easily do that in step functions. Just change the link to whatever you're pointing at. What if I actually wanted these to run in parallel? So it does the first thing and it does the next thing back to back. And then I want to run these 2 other Lambda functions at the same time. That step functions does this. That's really neat. So maybe I'm trying to do a batch job of a bunch of different image processing things, and I want them all to go at the same time instead of waiting for them one by one. What if some of them take more time? Like what if I've got really big files and really small files, but I want the whole operation to not continue forward until they're all done. That's kind of hard to do with Lambda at the base. Like even if you were able to execute, your 10,000 Lambda functions to go through all of your files you're trying to mutate, how do you tell them to wait for one like very slow Lambda function because it's got a big file? That's what step functions helps you do. And then what if it broke, right? What if I just want to try again? That's another cool ability of step functions is the ability to go back and it's like, hey, we need to retry this until we succeed or we fail out. And again, that's really hard to do with Lambda by itself. So step functions, very cool service. And it's not just Lambda. I mean, I know I was blabbing on about Lambda because that's what we just talked about, but step functions integrates with like, I don't know, all these guys. So I think it's like 15 services now. And so you can get a response from Lambda, batch, glue. You can request specific run jobs to happen synchronously. I think there's async as well. And you can wait for the callbacks from them for various cool stuff. So there's a lot of dynamicy and power that can come from creating a step functions based workflow. And in fact, you can create whole, what did I see? That AWS has a really good example of a step functions serverless based video transformations workflow where someone puts a video into an S3 bucket and it goes through and transforms it and encodes it into various different formats and like different files and then spits them out in the end in different buckets and whatnot. Very powerful stuff. So here's some examples, some specifics. I know I just had a chart there, but you could like run an Elastic Container Service or AWS Fargate task, a batch job and wait for it to complete. You can publish a message, and these can branch off or do at the same time, a bunch of different options. You can send a message to Amazon SQS, start Glue, all that cool stuff, yada, yada, yada. Has anyone told you I like step functions? So here in the middle, you can see this is what the code looks like for step functions. Since we're going to be writing serverless code, this is one of the things that you have to write code for. It's JSON formatted, Amazon specific step functions, markup-y, language-y type thing. You're not going to find it really anywhere else, but it kind of looks like a CloudFormation template and JSON had a child. But while you make it inside step functions, over here on the right, you'll see it will create a visual graph of what your code does. So that's super nifty. So here you can see we start here at the top of the code, start at submit batch job, and then down here notify success on the left, and maybe if it failed, it does notify failure on the right. And then the thing ends. It's very small. I did cut off the bottom though, so if it looks like it doesn't work, you're probably right. Here's a bigger version. This is the sort of the high level look at doing an image recognition and tagging setup using step functions. So maybe we start at the top where, again, an image is placed into a bucket of some sort, S3. We can extract the metadata from it, and that would be like a task. So that's just telling it to do something. And then we'd have a choice. So if we check the image formats, like, is this an unsupported format? If so, fail and be sad. But if this is a supported format, go ahead and grab all that metadata. When was the picture taken? How many, what was the resolution? And then push all that down here. We're gonna do a parallel task. We're gonna send to Image Reco, the cool service that AWS offers, and we're gonna create a thumbnail at the same time. Nobody likes to load the big image at once. Let's create the little, I don't know, the 50 by 50 pixel ones. And though it's not waiting here, it's just gonna continue forth on this side and add the Reco tags, maybe to a DynamoDB database or something, so that way it can be easily searched through. So we can find the image later and some sort of large website. That's pretty nifty. And this could all be done serverlessly, all be done with Lambda, written in TypeScript or PHP. My God, the power of step functions. You gotta have fun with this stuff. If you don't have fun with it, it'll bore you to tears sometimes. All right, so let's do a quick recap. What languages does Lambda support? I mean, I've got the answers here. Java, Go, PowerShell, Node.js, C#, Python, Ruby. Is it strictly limited to those languages? No. And that's something you probably wouldn't understand or realize when you're first sort of beginning. And how do we sort of get around and create your own language support? And we use this magic thing called Lambda layers. Nifty. And where can we find pre-built layers? Because I'm too lazy to do it myself. I mean, I let the professionals do my work for me, as they say. I'm a professional. You can find it in the Serverless application repository. Some more knowledge points. Why would I want to use this Serverless application repository? So you don't have to reinvent the wheel. Save yourself time and money and energy. Like, do something uniquely you. Don't waste time rewriting Dino. And so what is SAM? Relates to that above question. It's the Serverless application model. Allows you to build those templates just like CloudFormation with all the intricacies and power of CloudFormation, but more focused on serverless, more focused on allowing you to write functions in Lambda right in the code there. That's a little harder to do with just CloudFormation itself. And then what service do we have that orchestrates all of the previous garbage we just talked about? That's step functions, the vending machine service, the flow graph service that we just saw. Giving you a bunch of names, so hopefully it sticks in your brain. When you're going through the test, you're like, oh God, what was the thing Will said? It's the state machine. All right. Whew, Jesus. All right, I was trying to rip through that pretty quick. Hopefully I didn't blow your ears off. That was part one. So I'm gonna take a sip of the coffee. And what do we got? These all get shorter as I go through them. I thought the first bit was probably the most important. Translate functional requirements into application design. Blah, what does that mean? Like I said earlier, it's like, can you AWSify the problem? So like, I just want in your head, if someone says I need a MySQL database, like you go, it's RDS. Sorry, anytime someone says that, I want that like just like pounded into your brain. And anytime someone says they need a web server, you say EC2. Now you could get like quizzical about the top one. It's like, but couldn't I put my own MySQL database on EC2? I'm like, you could, but that's not probably going to be the answer on any of the tests. That's pro tip number one. The answer is almost always something related to AWS. I know that sounds silly, but if you've been in the industry for a long time, there are a bunch of different ways to do like any specific thing. Pick the one that's more AWS-y. That's the best I can give you. And can you create a solution where all of the pieces fit using those AWS services and solutions? I love writing. Writing's tough. So that's kind of what this whole part's about. So let's go through an example. This kind of thing is more of an architect-y type question, but I tried to developerify it. So let's read this out loud. You're a developer working for a large grocery store chain. Your boss needs you to recreate their inventory management system in AWS. The current system oversees notifying the local store managers when supplies are low and what supplies to reorder from a nearby distributor. The calculations with recommendations takes about an hour and a half to complete on average, but sometimes can take up to 3 hours. All inventory data per store is updated by 9 p.m. and gets stored in their corporate on-premises database. The system needs to check inventory levels every night so that an email with order recommendations is waiting in the local store manager's inbox the next morning. Oof. So how would we translate, like this is our requirement from our boss or whoever. They want us to sort of remake this thing, to build this. How do I turn this from a functional requirement into an application design? take it line by line, okay? When you get these questions, there's a lot of information, not all of it's important. So you're a developer working for a large grocery store chain. Lovely. I'm glad I have a job. It's tough to have a job in these difficult economic times and the 2020-21 years. So skip that bit. Your boss needs you to recreate their inventory management system in AWS. The current system oversees notifying the local managers when supplies are low and what supplies to reorder from a nearby distributor. When I see this sentence or series of them, I'm seeing the words notify. And so that means at some point, we're going to have to send that email out to the poor soul who has to reorder all of the bread. What two services, I mean, you can see them on the screen. I'm not hiding any answers from you. These are the two services that I think of when I hear that an email must go out to somebody. Sure, you could run your own EC2 server with a mail server on it. That's probably not the right answer. More AWS. Think AWS when you're doing the AWS test. So we've got the simple notification service on the left, and we've got the simple email service on the right. Cool. What's the difference between these two? Why would I pick one over the other? The simple notification service, it does a lot of things, but it does it very small. So the simple notification service can send email, it can send SMS. I think it can use your pager. I don't remember. But in general, the simple notification service can only send out, I think, 8,000 characters for an email, which, I mean, that sounds like a lot of characters, but it's really not. And what if we want to send a really long list? What if all of the bread needs replacing? We need a bunch of new bread. I don't think that's going to work. So I would look more at the simple email service, which only does one thing, and that's email. And it can do email really, really good. So that's kind of the thing I would think about. If our application that we're designing needs to send out email, it's going to touch the simple email service, probably. So let's look at the next bit. The calculations with recommendations take about 1.5 hours to complete on average, but sometimes can take up to 3 hours. So what is the two different types of compute that I've talked about so far? We've got the serverless option of Lambda, and we have the server option of EC2. There's also containers out there, but we're going to pretend those don't exist for this talk. Can Lambda run for 1.5 hours? Not really, right? It has a top end of 15 minutes. So if we wanted to do this with Lambda, the data on the back end would have to be able to be chunkified, that we could, I don't know, maybe in parallel go through all the calculations in little bite-sized bits, maybe per item, each item, one calculation instead of doing a whole database at one time. Then maybe you could use Lambda. But if we're not trying to get too cute, EC2 would probably be the best and the quickest route to just we could carbon copy whatever algorithm they're using onto into the application and just sit that on EC2. So depending if you want to go the easy route or the hard route, you could pick Lambda and try to chunkify your data and make it bite-sizable and serializable, or you can go EC2 and make it simple. I'm gonna pick EC2. I'm a simple guy. I think that's probably best for the solution. All inventory data per store is updated by 9 p.m. and gets stored in their corporate on-premises database. Depending whether or not our boss wants us to also migrate off of the on-premises database, we would need an RDS database to hold this information. If we're not forced to migrate all this data into the cloud, then you can just use their database. Something to think about. You could also use Dynamo if you wanted to. You could be fully serverless that direction. But I think if we're doing something as possibly complicated as dealing with entire grocery store's inventory, it might be better to do RDS so you can do complex queries to see, I don't know, make cool graphs like the cost of bread over the day versus how much people eat it. The system needs to check inventory levels every night so that an email with order recommendations is waiting in the local store manager's inbox the next morning. That's good. What we do know about this is we have a limited time frame, right? I think we got all of our, don't look at that. All of our stuff is in and ready to be calculated by 9 p.m. and realistically it needs to be done by 6 a.m., maybe 4 a.m. for some wiggle room. So just something to keep in mind and think about. That's what I think about when I'm going through these questions. So what does that look like? Whatever our final application is, this is sort of the functional design that we've come up with. Our application is going to probably sit here on EC2. It's going to need a reference to an RDS database, or it's going to need a VPN connection to some sort of on-prem database. At some point, it's going to have to talk to an email server using the simple email service and push it out to the manager's email. that's kind of neat. And so if you were looking at this test on a question, you would try to find, if you're looking at this test on a question, if you're looking at this question on a test, you would try to find whichever of the 4 answers looks similar to this. If they're asking you to do strange things with, you know, the image recognition service, trying to do live scans of the inventory, it's probably the wrong answer. So go simple, go AWS. And then I guess my next tip is follow your gut. Whatever you think your first answer is probably the right one. So how do we change this if we're designing for cost? That might be a question that comes up as well. Again, this is more of an architect-y question, but that's my background, so you have to deal with it. What do we change? Well, since we have EC2, it might be fun, instead of having this on like all the time, like maybe we're running 1,000 servers 24/7 day and night, that's going to cost a lot of money. We know the information's not even going to be ready until 9 p.m. So we can just set up a cron job to turn on all these servers. There's also, I think they just made the EC2 scheduler sometime a year or two back that can turn these all on for you. And then maybe you can have them shut off when they're done. So you know they'll definitely be done by 6 because they have to be. But you can just tell them when they're done calculating whatever load they have that they can go to sleep. You pick them up the next day. And suddenly you've just saved, I don't know, 20 hours worth of cost or 18 hours worth of cost. Things to think about. We're going to be smart developers, smart architects, blah, 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 blah. All right, let's go to the next section. Implementing that design we just talked about into application code. These next 2 sections are, they're hard for me to teach specifically. The best I can give you is examples, because a lot of the stuff you have to either know by having developed for some amount of time or having worked with AWS. Let me give you some examples of what I'm talking about, right? Oh, yes, they will not actually ask you to write code in this exam, so don't worry about that. But you will have to be able to read pseudocode and make decisions from that. I have heard from the grapevine that they might ask you to write code in the new exam that's coming up for sysops, if I remember correctly. But don't bet on that. Don't take my word. Take a look at this example. This is a pictorial example of lazy loading. By the way, if you don't know the different ways to that cache can be mangled with, go learn lazy loading right through and all that other good stuff. So for those of you who don't understand lazy loading, it's basically you have your application. It's a 1990s Dell computer or whatever, and that's what it's sitting on. And let's say you got a database over here on your left, it's RDS, and you have a cache sitting in front of it. Either this cache could be like, I don't know, CloudFront, just because that's closer to the person, or it could be just a cache that's to protect the database from getting abused by the application. So if the thing, let's say we want to look up how much bread is left in the inventory management, if that answer is in cache and it finds it, it's going to check this first. Boom, we've succeeded with 1 unit of time. But this is lazy loading. So if it wasn't actually put in cache yet, we check the cache, it wasn't there, 1 unit of time is gone. Then we go check the database. Good news, the bread inventory is there. That comes back and we put it in our application. That's 2 units of time. And then we spend another unit of time to go put it in the cache. So that way next time, for whatever poor version of our application has to come check for bread, it will be there. And that's 3 units of time. So you can see if it's in the cache, this is a great method. It only takes 1 unit of time. If it's not in the cache, it's vomit-inducingly slow. Which one of these examples is lazy loading? Like, let's take 30 seconds here. Please read the code. It's a pseudocode. You should pretty quickly have an idea of which one is lazy loading and which one's not. I'll just take a moment. I'll have my coffee. What do we think? Top or bottom? Which one smells like lazy loading? And the answer is coming in 5, 4, 3, 2, 1. It was the top one, because I'm also lazy. So I was hoping that the first one, it triggered your memory better. So you can see here, if we go through, we have some function called get customer. Sorry about the formatting. And we're trying to save a variable called customer record. It's asking something called cache to get something with a customer ID. If the customer record is null, if it's not there, then customer record, whatever we're currently holding that in, is equal to a database query where we're selecting from the customer table where the ID is the customer ID. And then, so we've saved it somewhere, and we cache that. So we go to cache, we set all of that garbage, and then we return the customer record. Down here is just write through, which is when you're writing stuff. So it's just the customer record. So we're saving a customer. That's the first clue right there. Get customer, save customer. The is equal to a database query where we're updating the customer IDs, and we're just setting the cache immediately. So two different scenarios, two different versions or reasons to use these. Hopefully you got that this was lazy loading. If this was a tricky question, I recommend studying more. Please don't take the test if these next series of questions are very difficult. Please go study, go on the website, run through the learning paths. All right, like I said, these sections are short because it's hard for me to give you direct lecturing to it. It's just something that has to come with time. Write code that interacts with AWS services by using APIs, SDKs, and AWS CLI. What does that even mean? Well, basically, they're going to ask you strange questions like, what is the tag that you would use when changing an EC2's device mapping, block device mapping? And it's literally, do you know that this is the API call to do that? Luckily, there's going to be 4 options there, and I mean, block device mappings is a pretty easy one to figure out, but maybe they get tricky down here in this bit. So this is where things get spooky. Like, you kind of have to know it, and the only way to really get better at that is to go do labs. So if you can go into the website and go do some labs that are more developer focused, and I will give you at the end some of the things you definitely need to study that will help you. So let's take a look at another example of this. So we were speaking about SAM earlier. Here's all of the CLI commands for how to build that SAM file. And remember, part of this domain is writing serverless application code and developing for it. I'm not in charge of the deployment of it. I'm not in charge of the deployment side, but this is an example of that. So you should be familiar, at least be able to read and understand these type of inputs. Excuse me. Here's a question I stole. Take a look at this. It's from a very old version of the developer test, but it's still very applicable. Read the question and try to find the answer. I'll give you a few moments. So this is a question that deals with how well do you know CloudFormation? And do you know the intricacies of, excuse me, of how to burp? Do you know the intricacies of what is the format for, this is resources and mappings and checking for a region map, which one of these, if plugged in with this sort of JSON snippet, would give us the result of AMI 6411? Like, you just have to know this stuff. It's really hard for me to teach it. You have to practice it by doing a lot of CloudFormation and just understanding by writing it which one of these is the right answer. And hopefully, the answer is D. I forgot to put the response here, but it's down here, is finding the map, region map, the variables region map, and it picks up your AWS region, whichever one you're in right now when you're running the CloudFormation. And the secondary key is 32. They both have 32, so it's this puppy down here. Again, it's a tough one for me to teach it. You just have to go spend the time. Let's take a look at this question. We'll take a moment to read it. This is a very common type of question, mostly trying to confuse you, in my opinion. But you will know the answer, kind of, if you've worked with Lambda and you've worked with API Gateway. This talk probably should have had API Gateway in it, but I would have run way over time. So what's the answer? Let's read through it. A developer is building a web application that uses Amazon API Gateway. The developer wants to maintain different environments by development, and production, dev and prod workloads. The API will be backed by an AWS Lambda function with 2 aliases, one for dev and one for prod. How can this be achieved with the least amount of configuration? Okay, anytime they bold something and make it really big like that, that's the most important thing. Please God, don't forget that. So let's read through these. Create a REST API for each environment and integrate the APIs with the corresponding dev and prod aliases of the Lambda function. Then deploy the 2 APIs into their respective stages and access them using the stage URLs. That sounds like 2 things and then 2 more things. Keep that in mind. Create one API gateway and integrate it with Lambda function with the Lambda function using a stage variable in place of an alias. Then deploy the API to 2 different stages, dev and prod. Create a stage variable in each stage with different aliases as the values. Access the APIs using the different stage URLs. Even though that sounds like a lot, this is actually just like 3 things. So I like that one more than the other one. Create one REST API and integrate it into the dev alias with the Lambda function. Deploy it into a dev environment. Configure a Canary release deployment for prod, where Canary will integrate with the Lambda prod alias. This is confusing because Canary is a deployment method where like you send 10% of your traffic to one thing to see if it dies in a coal mine, and leave 90% of it on the main product. So this seems strange. And this other one is another version of Canary, which is being also very strange. So I don't like those 2 at all. And since B has less things than A, I'm going with B. Is B. Look at that. With deployment stages and Amazon API Gateway, users can manage multiple release stages for each API, such as alpha, beta, and production, using stage variables that can be configured. An API deployment stage can interact with different backend endpoints. Users can use API Gateway stage variables to reference a single AWS Lambda function with multiple versions and aliases. Cute. All right, that's pretty much the end of my talk, but here are those tips I promised I'd have you. These are the 6 services you 100% need to know and study like the back of your hand. CloudFormation, very important. S3, DynamoDB, RDS, Lambda. I hate putting this one on here, but Elastic Beanstalk, for some strange reason, AWS is very fascinated with Elastic Beanstalk. They love it, they love it, they love it. I wish it would go away because it teaches you bad things, but you should know it for the test. You should also read the following white papers. Practicing continuous integration and continuous delivery on AWS. They're very boring, I'm sorry. I'll write a video one of these days and put it on the website going over a highlight of the important stuff. Blue-green deployments on AWS, running containerized microservices on AWS. These 3, there's a bunch that they say to go read, but these 3 are like, I don't know, the 80-20 rule of white papers. Just at least browse through them and try to read them if you can. This is my biggest tip, read the FAQs. The FAQs are a secret gold mine, excuse me, that the developers of the test pull a lot of questions from. These 4 things alone are probably where all the test questions come from themselves. Read the FAQs. Read the FAQs for each of these services, and that will take you so much farther than you can imagine. I was able to get the architect certification when I first started many moons ago within 28 days, just by reading the white papers and the FAQs and doing a bunch of labs. So if you can do that, do a bunch of labs, read the white papers, read the FAQs, you stand a very good chance of doing okay on the test. I'm not saying you'll really fully integrate everything in your brain after only 28 days, because this takes a lifetime to really get good at, but you know, it's a good shot at it. I also recommend taking the practice test. Your comprehension of a subject statistically will go up, even if you know nothing about the subject, if you take a test on it. So if I gave you a subject on the anatomy of squirrels, or I gave you a test on the anatomy of squirrels, and you knew nothing about that, just after taking the test, you would know more. And it will help you get in the right zone and the right frame of mind to take it again. Things to think about. I also wanted to show you this horrific monster that I found in one of the other white papers recently, doing research for this webinar. Oh boy, this is their version of a modern serverless web application with CI/CD and analytical use cases. So though I say before you take the test, you should at least be able to tell me 2 sentences about every single one of these services. I'm very sorry, I know that sounds scary, but definitely know the differences between all of the different code things. Know the differences over here between different compute things. How do I do users? Cognito over here, kind of cool. Analytics is kind of meh. You probably won't have to worry about analytics. If you want to skip something, skip analytics. Something to think about. And that's it. What do you guys think? Do you have any questions? Now's a good time for questions. Excuse me. All right. We'll give just a couple more moments. I'll stretch. Have some coffee. Alrighty dighty, well, it appears everyone's very silent, so I think it's a good spot to stop. I hope you guys enjoyed my TED Talk, as it were, and I hope you had fun. Like, that's my most important quality for a webinar, is I hope I didn't bore you to tears. Please let me know, send us feedback. It helps. Let us know what we should have talked about, what you were hoping this was, and what you liked about it. Most importantly, let me know what you liked, because positive feedback makes me happy and lets me know I'm doing a good job. What is layers and Lambda? Oh, there was a quick question that came in. Layers was that thing that allows us to bring in our own code for if we want to use PHP, for example, which isn't natively supported. It can also do some other cool things. Any other questions? One did sneak in. Okay, well, I think that's a good spot to call it. I hope you all enjoyed. I've been Will Meadows, and I will continue to be Will Meadows. You be you. Have a great rest of your day.